this is that I'm going to plug in my values. I get 0 equals 0 plus 0 times time. Not 0. Like that. True, right? Incredibly long. Okay. So this is one of these things where it works, it's true, it didn't help me find the time. The other equation I have that has time in it is x final equals x initial plus vx initial delta t plus half ax delta t squared. So I'm going to plug in, I've changed the s's to x's because I'm working in the horizontal direction at the moment. So my final x is 50, my initial is 0, my initial speed is 25, I don't know the time, and my acceleration in the x is 0. The x direction is really easy in projectile motion because a whole lot of stuff is 0. The accelerations are always 0. So this is solvable for the time. And when I do it, I get a time of 2 seconds. That didn't answer the question. The question asked for the height, but I have to find the time before I can figure out the height. So now I come over into the vertical column, where I've got a time down here of 2 seconds. I know these two values, I know this value. I'm missing 2 values in the y table. And the way that this works is if you're missing 2 values in the y table, you can solve for both of them. If you're missing 3, you're in trouble. But if you're missing 2, you can solve for both of them. So again, you got to decide which equation to use. If you're bad at that, then you should just pick one and start putting it in. These boards are horrible. For teaching, these boards are horrible. You guys can see the writing on them? They're really chalky. Okay, so I don't know. I'm just going to pick one. This is the one that comes into my head first. That one always comes into my head first because it's easy to remember. So this one I've got, I don't know this. That's not given. This is 0. My acceleration is negative 9.8, and my time is 2 seconds. So I've just found that the final velocity is negative 19.6 meters per second. So, okay, they didn't ask for that, but I found it, so that's okay. I want to go on to the next equation, y final, is y initial plus vy initial delta t plus half ay delta t squared. So my y final hits the ground. Y initial is what I'm looking for. That's the goal. My initial y velocity was 0 because it was fired horizontally, right? Not vertically. I know the acceleration. Got to put the negative in. And I know my time. Got to square it. I end up with an initial position, if I do this math, of 19.6 meters. Okay. How is that? Is that okay? This is kind of one of like the simplest two-dimensional problems you can have in kinematics. It's fired horizontally. It gives you a bunch of zeros. The only link between the two sides, you just have to find the time on the x and move it over to the y. All of the two-dimensional problems that we do, almost all of them, you have to think about both dimensions. You usually have to solve for time in one and bring it over to the other side. It's really unusual that you can just work in one dimension if it's a two-dimensional problem. Okay? Questions about this? Okay, let's look at a more complex problem. That's a really complex problem. Let's go now. These are really complex problems. I'm going to make one up that's a little bit easier. Okay, so let's do one where we've got a ball that's fired 20 meters per second at an angle of 30 degrees. So let's say it's a soccer ball. Somebody kicks a soccer ball. Soccer ball is kicked at 20 meters per second. It's kicked at a 30-degree angle. It's going to come all the way over here. And the question is, the maximum height. And I want to know how far it goes. I want to know both of those things. And this is where we're going to bring vectors in to help us solve this problem. Because I'm given this speed, but it's not a horizontal or a vertical speed, right? It's not the horizontal speed, it's not the vertical speed, it's some combination of both. So for our table and for our equations, we need to know the x component and the y component of the velocity, and that 20 is not either one of those. So I can't put that 20 into my table, I can't plug that 20 into any of these equations. I have to use my knowledge of vectors with that speed and that angle to figure out what the x and the y components are. So I'm going to make a table again. I'm going to plug in what I know. Okay, so based on my picture, I've chosen to put my 0 point at where I kicked the soccer ball. So my initial, okay, so my initial position of this soccer ball is 0, 0, right? It's on the ground and it's at my 0 coordinate. So I can write this as 0, 0. Now, the table changes whether I want to talk about the max height or I want to talk about the max distance. So this table is specifically my max height table. So my final position is my max height. The other thing I know my A acceleration is 0. I know my Y acceleration is negative 9.8. What do I know at the very top up here? Which velocity is 0? The y velocity. So if I throw something straight up, we say at the top the velocity is 0. It's turning around, right? So it has a 0 velocity. If the ball is coming like this, at the top it's only turning around in one direction. It's still headed in the x, right? But it is turning around in the y. So at the maximum position, maximum height, this is 0. The x velocity is not 0 at the max height. If it was, it would just fall straight down when the ball would go boom. So it has to continue to have the same velocity in the x direction it had before. We know, in fact, right, that these are the same. So that rule still holds true that you learned in free fall. You learn that at the top, when a ball's in free fall, that the velocity is 0. That's still true, but it's only the y component of the velocity that's 0. Okay, so the only other thing, oh, I screwed up. Sorry. Is this the attendance from this class? So I have initial speed information, but I have a value and an angle. I can't plug that 20 into my table. I have to do a little vector problem to figure out my x and my y components. So let's do that real quick. So I've got a vector speed of 20 meters per second, an angle of 30 degrees. And I can draw my components in my triangle form. This side is adjacent to the angle. This side is opposite to the angle. The adjacent side is always the cosine side. So this is 20 cosine 30. Because it's the adjacent side. my students screw this up all the time. If I give them that angle, they can't do the problem. Right? But if I give you that angle, this would be a sine, because it's the opposite side. So don't think students tend to equate x is cosine, and that's not the right way to do it. Adjacent is cosine, and opposite is sine. Okay. Let's go to one of those things. So, I think I'm in radians, hold on. So 20 cosine 30. Sine. So I get 17.32 and 10. So I have to do this little side problem to be able to do these problems. I have to do this little side problem with a little vector problem, pretty easy little vector problem, before I can figure out what to plug into my equation in my table. So it's not until I do this that I can plug in 17.32, 17.32, and 10. Okay, so I told you guys that if you have if you're missing 2 over here, it's solvable. Turns out that's not true for the x. Because it is 0 acceleration, it wipes out a couple of your equations. So it turns out that I couldn't, no matter what I did, and this is something you'll just remember with practice, no matter what I did, if I started here, I'd be stuck. Okay? And like I said, if you can't see that path, you've got 6 equations. You've got the 3 for the y, the 3 for the x, just start plugging into them if you can't figure out what to do, and you'll eventually realize what to do. So I've done this for 15 years, so I know what to do. I'm going to start on the y, and I'm going to use an equation that doesn't have time in it, because I'm interested in the max height. So if I can find the max height, I can answer the question. And I need an equation in the y that doesn't have time in it. And the only equation that we know that's like that is vy final squared is vy initial squared plus 2ay y final minus y initial. That's the only equation we've got without time. And again, I don't expect you guys, I never expect my students to be able to know. The professors stand up here and they go, who do we use this equation? Right? And it's typically not clear to most people in the room. So, like I tell my students, I know because I've been doing this for a really long time. I took this class 20 years ago. That's really depressing, but it's true. So, I've been doing this for a really long time. So, don't think you should be able to pick out the equation and know which one to use. Don't think you should be able to do that. But what you should be able to do is start plugging into them until you find the right one. Okay, so my final speed, I'm at the top, right? So this is 0. We found from our little vector problem that the initial is 10. I know my acceleration is negative 9.8. I don't know my final position, but I know my initial position is 0. And if I go through and rearrange all this, I get 5.10 meters. Now, the next question was how far does it go? And I have to make a new table because my table is based on my final position, which is the max height at this point. So I have to actually do a whole new table in order to do the next part of the problem. So my x table is the same, because I really didn't do anything with that in this case. But I'm just going to do one. I need to get like a stencil made where I can just chalk through on a piece of paper, you can stamp out your little table. So I've got x initial, x final, x initial, x final, ax t, y initial, y final, dy initial, dy final, ay delta t. And this table is for to the ground. So from start to the ground. So this table was the max height, this table is to the ground. And a bunch of this stuff is still the same. I still start at 0, because that's where I put my origin in my picture. My initial speeds, I'm still at the same initial point, so my initial speeds are still the same. So I don't have to redo that vector problem again. These are still the same, always, always. My x acceleration is always 0. My y acceleration is always negative 9.8. And I know one other thing. What's that? Y final is going to be 0. It's back on the ground again. So I know this too. Back on ground. Okay, so again, just from my experience, I know I need to start on the y side. And I need to find the time, because it's the link over to this side. I'm asking for the total distance traveled, so that's what I'm looking for. So this is another one of these things. If I started with the x side, I wouldn't be able to find anything. I just know that from experience. You guys might have to try it. If I go over to the y side, I can find either one of these things. We're going to find them both because I want to show you something about the final velocity. And then I can bring the time over this side. So I'm just going to fill in the whole table. Okay, so let's look at y final squared, same one we did a second ago. Now when we used this in the first part of the problem, we knew both of the velocities and didn't know both of the heights. Now we know both of the heights, we don't know both of the velocities, so I can still use it. So my final, I don't know. My initial is 10. My acceleration is negative 9.8. And my y final is 0, and my y initial is 0. So, love zeros. This tells me that Vy final squared is 100 meters squared per second squared. Now, this is one of those things where we have a square root. I'm sure you guys have seen this before. Mathematically, there's two answers to this. Mathematically, I have to write Vy final is plus or minus 10. Because both of those squared give me 100. So in math class, you'd circle that, you'd be done. But in a physics class, only one of them is physical. They're both mathematically correct, only one of them is physically correct. Which one is it? It's headed down that way. So it's got to be the negative one, right? It's headed down into the ground. This is tough, but it's got to be the negative one that's the physical one. Okay? If we were finding the initial, and we got a plus or minus, then it would be the positive one. So I know then that Vy final is negative 10. What I want you to see is that that's the same speed we started with in an opposite direction. And that's kind of a general rule. If the height is the same, the key is the height being the same. The reason that worked is because in the math, because the y final and the y initial were both 0, if they had both been 10 meters, would it still work? You'd still get 0 from this. If they're both 100 meters, they'd still cancel out, you get 0. If you start and end on the same height, then the velocity is the opposite of the beginning, right? The velocity of the end is the opposite of the beginning. They're the same speed at the beginning and the end, opposite directions. So be careful when you use that, if you want to remember it. I have students all the time, then I get a problem where like, you kick a soccer, I don't know if I'll ever kick a soccer ball off a cliff, but you kick a soccer ball off a cliff, right? So it starts here and ends up down here. Now that's not true anymore, because the heights are different. Or you kick a football, right? And the football goes through the goal. So here comes the football through the goal. The start and end point are not the same anymore. So this is only true that you get the same value you start with, negative. It's only true if you start and end on the same height. Okay, so how well does that help me? Because I need to find the final x. But I can plug this into my table, negative 10. So now, hopefully, it's fairly obvious that I can now find the time. It's the only thing left in there. And if I know the time on that side, I can pop it over to here. So I'm going to do that. We have two equations that have time in it. The easy one is always the one without the time squared, typically. Because the time squared one, sometimes you have to use the quadratic equation. So if you can get away without using the time squared equation, life is usually easier. So this is the other one we have that has time in it. So my dy final was negative. My dy initial is positive. My acceleration is negative. And I've got my delta time. If I messed up and didn't think about this negative sign, I would get a time of 0 here. Right? If I had messed up and made this positive, I would have found time equal to 0, which should be a big red flag to you going, time cannot be 0, that doesn't make any sense. I have done something wrong. It's so easy to forget that negative sign. It happens, I do it, it happens all the time. So you look at your answers, right? I'm sure Dr. Bustos told you this, always make sure your answer makes some kind of sense. So if I go through and do this, I get a time of 2.04 seconds. Did we find the time to the max height? Did I ever find that? Okay. If you do go back and find the time to the max height, you would find that it was 1.02 seconds. Again, the same height, right? The time it takes to get to the top has to be the same time it takes to get to the bottom. But that's, again, you've got to be really careful with that because that's only if it's the same height. So I still haven't answered the question because I need this x final. And at this point, I can really use any equation. Since I need x final, I'm picking this one. My x initial is 0. My b initial, sorry, 17.32. We just found the time to be 2.04 seconds. And my x acceleration is 0. So that last term always ends up being 0 for the x direction. So I get a final of 35.9.